So this question says 1 mole of an ideal monoatomic gas. So again the gas is ideal, so we can always write PV is equals to nRT. So the gas is ideal, and this is also given, this is a monoatomic, so CV is 3/2R. So the gas is monoatomic, that is given to you. So this is monoatomic gas. This means I have to have CV is 3/2R. Now this gas is taken through the cyclic process A, B, C. Yes, this is the cyclic process. I'm starting from A and finally coming to the A. The process is cyclic. So we have to calculate the work done by the gas during this process. So work done, so first is work done by the gas. That is easy to find, work done by the gas. That is basically integral P dV. And this is same as integral P dV is area of the curve, area of this cyclic process inside this PV diagram. So this is same as, so if you remember, this is same as area under PV curve. So this is same area under PV curve. So if I find area, that's fine, area under PV curve. So if I somehow find area, that will give the same answer. So you see area is what? This distance is V0 and this is a triangle. So half times base is V0. What is the height? So this is 3P0 minus P0, so that is 2P0. So you will have this is P0, V0 is the area. So this is the work done in the process by the gas. So this is the work done is, so this means work done by the gas is work done by the gas so this is basically P0, V0. Now B part of the question says the heat rejected by the gas in path CA, and this is a heat, not a heat, this is basically heat absorbed by the gas. So let me write here, so this is a heat absorbed by the gas in path AB. So in CA, and so what is the heat absorbed in the path CA? So let us say discuss path CA first. So what we will do is, so for path C, so let us discuss part 2 of the question. So this is part A. So if I see path CA, what is the work done in path CA? So first find out work done in path CA, that is same as integral P dV. You see in this case pressure is constant, so isobaric process, the pressure is P0. So I can write pressure is P0 integral dV, and dV is initially dV is 2V0, final is V0. So this is P0 V0 minus 2V0. So this will give you minus P0 V0. So this is the dW. Are you getting? Now what is the change in internal energy on the process CA? That is, I need dU. So this is same as NCV/dt. So somehow if I find dt, what is the temperature at C and what is the temperature at A, we are done. So you see, I know the pressure and volume and the 1 mole of the ideal atomic gas, so I can always calculate what is the temperature at C. So you see, we can calculate temperature at C easily. So temperature at C is equals to, if I apply PV is equals to nRT, so PV is equals to nRT, so PV by nR will give you temperature. Are you getting or not? So what is the pressure? Pressure is P0. What is the volume? 2V0. What is the number of moles? So this is 1 mole of ideal atomic gas, this is 1, and this is simply R. So this is 2P0 V0 by R. Now calculate the temperature at A. Similarly we can calculate PV by nR. And now what is the pressure? Pressure remains same and the volume is V0. So P0 V0 divided by 1 into R. So this is the value of temperature at A. Now temperature at A minus temperature at C, that will give you dU. So this is NCV dt. So temperature to N is 1, CV is monatomic gas 3/2R, and temperature at A, that's this, and that's C is this. So I can write this is minus P0 V0 by R. So R cancel out, so we will have minus 3/2 and P0 V0. So this is the basically dU. So now we can calculate dQ. So dQ is nothing but dU plus dW, and dU is what? Minus 3/2 P0 V0. This is the dU. And what is dW? dW is again minus P0 V0 in this process. So this total is minus 5/2. So minus 5 by 2 P naught V naught is the dq in this process. So this is the dq for path CA, minus 5 by 2 P naught V naught. You see, so again we have to calculate what is the net heat absorbed by the process AB. So we can do the same thing for process AB. So you see, process AB. So now the third part of the question. So let us first calculate dW for process AB. This is PdV, and now this time it's easy because volume is constant. So isochoric process, work done is 0 in the isochoric process. So this is basically a isochoric process. So isochoric process. So in isochoric process, volume is constant. So volume is constant. This implies dV is 0. So dV is 0. This implies dW is 0. So this is easy. Now I have to only find dU, change in internal energy, that is NCV dt. Now I know the temperature at C. Somehow if I find temperature at B, so temperature at B is, again I apply the same ideal gas equation. Only thing is pressure I have 3 P naught, volume I have V naught. So temperature will be, so temperature is PV by NR. That will give you temperature. So what is volume? What is volume? Volume is V naught. You have already seen. And pressure is 3 P naught. So you see here. So this is point B. At point pressure is 3 P naught and volume is V naught. So at point B, now I can write this is a point B basically. 3 P naught divided by number of mole is 1 R. So this is 3 P naught V naught by R. So I can write N is 1 mole, CV is 3 by 2 R. And what is dt? So dt is, this is going from A to B. So final B minus, so this is going from A to B. So B minus A to TV minus TA. So TV minus T I have to write. What is temperature at A? So let us say temperature at A, again I can find. Volume is V naught and pressure is P naught. So temperature at A we can write. This is P naught V naught by N is 1 into R. So this becomes 3 by 2 R. And TV is nothing but 3 P naught V naught by R minus P naught V naught by R. So this becomes 2 P naught V naught by R. R goes out. So if R cancels out, so this is R. So 2 P naught V naught by R you have. So this 2 goes out. So we will have R also goes out. So we will have 3 P naught V naught. Are you getting it now? So this is the du. So what is dq? So dq is du plus dw, and dw is already 0. So this is the dq in process AB. Are you getting or not? The question asks net heat absorbed during the process BC. So we have to also calculate net heat absorbed during the process BC. And now this is easy to find because I know net heat of process AC, process AB. So and total change in internal energy is 0. And we have already calculated work done. So what is the total work done? Total work done during this process, that is P naught V naught. So now I can apply this one. So total work done is P naught V naught. So dW total is equals to P naught V naught. What is du total in this process? So du total is 0 because this is a cyclic process. Now what is the dq total? So dq total is, I know the work heat in process AB, and I know the in process CA is minus 5 by 2 P naught V naught, minus 5 by 2 P naught V naught. I also know in the process this is AB, that is 3 P naught V naught. So I have to add plus 3 P naught V naught, and then I have to add the heat changes in process BC because we have not calculated for BC. So heat changes for process BC. So this is this plus dq BC. So now I can write dq is equals to du plus dw. So dq total is 3 P naught V naught minus 5 by 2 P naught V naught plus dq BC is equals to du plus dw. Du is 0 plus dw is P naught V naught. So I can calculate dq Vc. So this dq Vc is basically nothing equals to P naught V naught. So this is 3 by 2 minus 6 of half P naught V naught. On this side it goes plus. So this becomes minus P naught V naught by 2. So this is P naught V naught by 2. So heat changes in process BC is simply P naught V naught by 2. It's easy. Now see, we have to also calculate maximum temperature attained by the gas during the cycle. So when you will have maximum temperature, that's a good idea. Are you getting or not? Okay, so we have to find T maximum. So let us say, this is the one important point we have in this program. So finding T maximum. So we want to find T maximum. How we'll proceed for finding T maximum? You see, we have equation, the ideal gas equation, that is PV is equals to nRT, and our number of mole is fixed, R is fixed, so I can write temperature is equals to basically PV by RT. So PV by nR, of course. This is PV by nR. So I will have PV by nR. Now see, if I have constant temperature, so let us say discuss something. So if I have a PV diagram and volume this side I have, pressure this side I have. If a constant temperature, I plot a graph. So let us say for a given temperature. So if I say temperature is constant and there is isothermal process, if I plot a isothermal process on PV diagram, that is temperature is constant, this means PV is equals to constant because number of mole and R is constant. So temperature is constant, I can say PV is equals to constant. So you will have basically hyperbola. So this is one hyperbola you will have at temperature T1, and if you have temperature T2, you will have another hyperbola, but this time the constant value will be higher. Similarly, you have temperature T3 and T3 is greater than T2. In that case, you will have again hyperbola, but the constant value will increase. So in this case, I can say T3 is greater than T2 is greater than T1. Are you getting or not? Now we will use this idea to find maximum temperature. You see, this means if I have P into V is more, temperature will be more. So what I have, this means I want T maximum. This is same as to find maximum of product P into V. Are you getting or not? So we are interested in maximum product of P into V. You see here, you have, if you see this graph, what is the maximum value of P into V? So this side you have 2 V naught and this is P naught. So maximum value is 2 P naught V naught. So maximum product value of PV. So maximum product value of P into V, I am interested. And this side I will have 2 P naught V naught. So this is 2 P naught V naught. Now what is this value this side? This will be 3 P naught maximum, and the value is V naught. So in this process AB, maximum temperature you will have, that is basically 3 P naught V naught divided by nR. That is, and in this process you will have 2 P naught V naught by nR. Are you getting or not? Because they follow the ideal gas equation. So process AC, you will have maximum temperature at C because the product is maximum. So you will have 2 P naught V naught by R. And on process AB, the maximum temperature you will have at B, 3 P naught V naught by nR. Now you see this path BC. Any point, if I consider any point on path BC, let us say this point, this will, the product at this point of P and V will be more. Are you getting or not? So at this point, product of P into V will be more. You see, if I see this point, this is a part of this kind of hyperbola. So this is a part of this hyperbola. So P into V will be more. If I see this point is a part of lower hyperbola. So I am 100% sure the maximum temperature will be attained somewhere on path BC. This point you have to understand. So maximum temperature we will get on process BC. So I know now maximum temperature will be achieved in process BC. So maximum temperature will be achieved in process BC. Are you getting enough? Now this is mathematics only. Now we have to do mathematics. You see, we have to find equation for this process. So what is the equation of BC? So I can write equation. So let us say at any point I have pressure is P and volume is V. So I can write equation of this line, and simple. So you see, what is the slope of this line? So you can say slope M is equals to by 2 minus by 1. By 2 is 3 p naught minus p naught, that is 2 p naught by 2 minus by 1 divided by, so this is my by 2, this is my by 1. So by 2 minus by 1, coordinate here is p naught. So by 2 minus by 1 divided by x2 minus x1. So what is x2? V naught. What is x1? 2v naught. So this is minus v naught. So slope is minus 2 p naught by v naught, and this line passes through. So I have to have equation of line. So let us say y is equals to mx plus c. So y is equals to mx plus c, and the minus 2 p naught by v naught is the slope. So y is equals to m, and on the y-axis we have plotted pressure, on the x-axis we have plotted volume. This is y is equals to mx plus c. Are you getting or not? So you see, pressure is equals to, that is y is equals to mx plus c. M is 2 minus 2 p naught by v naught, and this line passes through, at least I know one point, p naught to p v naught. So this point is p naught to p v naught. So p naught to v naught, it passes. So I can satisfy p naught to v naught. So if I plug, I can get the value of c. So p naught is equals to, this is basically minus 2 p naught v naught. So there is some mistake. So let us say I can wrap this one. So this part is simply minus 2 p naught v naught. Are you getting? Simple. Now, so this p naught is minus 2 p naught by v naught, and the volume is basically 2 v naught plus c. So what is the value of c? So this v naught goes. So you have c is minus 4 p naught plus p naught. So c is 5 p naught. Simple. So 5 p naught, that is equals to c. If I plug the value of c here, so I have equation p is equals to minus 2 p naught by v naught divided by v plus 5 p naught. So this is p. I need temperature. So what is PV is equals to nRT? If I apply, PV is equals to nRT. So I can write pressure is basically equals to, I need temperature. So I have to eliminate either volume or I can eliminate either pressure. So I need temperature as a function of something. So what is pressure? Pressure is nRT by V. So let us plug this value. So nRT by V. So this is pressure is equals to minus 2 P naught by V naught and V plus 5 P naught into V. So if you see, this temperature is equals to 1 by NR, and this we go this side, so we will have minus 2 P naught by V naught, and this is V square plus 5 P naught V square. You getting or not? So let me check again. So this is no V naught here. You have only simply 5 P naught. So there should be no V. So this V is not there. So this means there will be no V square. Are you getting or not? So simple. So I have to basically differentiate. Temperature is a function. So I need maximum temperature. So this is dt by dV. This is equals to 0. So if I do this, now things are easy. So you will have 2V differentiation minus and 2P naught by V naught. So this is the value here you have, and here you have plus 5P naught. Now if you solve this one, so what is the value of V? So V is equals to, you see, 5P naught V naught and divided by, so you will have 4P naught V. So 4P naught, so this is the volume, so 4P naught simply. So you will have 5 by 4 V naught. Now if you plug this value, you will get the maximum temperature. So you have T maximum, and that is basically you have 1 by NR, and this multiplied by minus 2P naught V naught minus 2P naught by V naught square. So this is 5 into 5, 24, 25 by 16 V naught square, and then you have minus or plus you have 5P naught V. So plus 5P naught and into V. So V is what? 5 by 4. 5 by 4 you have, and this multiplied by V naught. Are you getting or not? So you have to have V naught here also. Yeah, so this is V naught. So next time I have to take slightly bigger page. You see, so what we have? So I have, if I do calculation, so this comes of 1 by NR. And this is simply 25, so 25 by 8, so this is 25 by 8 with a minus sign. P naught V naught, P naught V naught. Now what is here? So 25 by 4. So plus 25 by 4 P naught V naught. So if you subtract this, what you will have? You will have 1 by n r. Are you getting or not? And then you have here, so this value you have, so 25 by 8, because this is half, so simply we will have 25 by 8 with the plus 1. So you will have 25 by 8 P naught V naught. So finally I can say this temperature maximum is equals to 25 by 8 P naught V naught by nr. Are you getting or not? You can verify yourself. This is a maximum temperature, that is d2T by dV square should be less than 0, because it's a maximum temperature. So you can verify yourself. This is a condition of maximum. Are you getting or not? So you check here. So this should be satisfied. You see, if you differentiate again and this equation, so this is the equation for temperature dV by dt. So we have plotted, so this equation again differentiate and put T is equals to T maximum, will get the condition for that temperature, you will get the condition for maximum. Simple one. So this is the one important point what we have to find the equation of a line, and if I know the equation of a line, I can differentiate. It is easy to realize that the process BC will have maximum temperature, because I said this is a part of bigger hyperbola. If you see this process, so this process is a part of bigger hyperbola. So product of P into V will be higher always. Are you getting or not?